Hi there and welcome to Penguin Learning. In this first National 5 lesson on the channel, we are going to be looking at how we can calculate the area of a triangle using trigonometry. We will begin by focusing on what the two ways are of calculating the area of a triangle, with these being with and without trigonometry, and we will go over several example problems using trigonometry in order to solve an area. And finally, we will have a look at proving how both of these ways of calculating an area with and without trigonometry are both the same and give us the exact same answers. So, let's get started.
Ooh la la!
Okay, so within some of our previous National 4 lessons, we introduced the concept of trigonometry and how we can use trigonometry to solve several problems. One of these problems was when we had a right angled triangle and we know either one side within the right angled triangle, one length, and the known angle within side. What we could do is use SOHCAHTOA or trig ratios in order to figure out one other side within the right angled triangle. Or conversely, if we know two sides within the right angled triangle, 2 out of 3, then that would allow us to calculate one other included angle within the right angled triangle. And the purpose of trigonometry, how we were allowed to do this, was by using the sine, cosine and tangent functions, the start of the SO, CA and the TOA. It was these trigonometric functions that allowed us to calculate this and solve the problem with right angled triangles. And in this lesson we are going to introduce another application in which we can use trigonometry to help us solve a problem. And in this case it's going to be solving for an area of a triangle. And unlike trig ratios, which was only limited to right angled triangles, this problem is going to allow us to solve the area for any different type of triangle. So one way that we've touched on in the past to solve for an area of any triangle is by this formula right here, which reads as the area is equal to a half multiplied by the base of the triangle multiplied by the height. And again, just to recap, the base is the bottom surface of the triangle, so it depends on the orientation, but the base is always a horizontal surface that runs across the bottom, and then the height is the perpendicular distance, or the distance up and down, the vertical distance from the base to the top of the triangle right here. But sometimes we might be given a problem where we don't have this vertical height. We might be given, in other circumstances, just the length of maybe this side, or perhaps this side right here. Or we might also be given an angle within the triangle, and then we have to use that information in order to calculate what the area of the triangle is. And that would mean that it would be helpful to maybe have another formula in order to calculate the area of a triangle if we are in the situation where we cannot calculate what the base or the height of the triangle might be. This formula is always 100% correct, but sometimes it might be impossible to figure out what the base or the height of the triangle is. But before we have a look at any other formula that's going to help us calculate the area of a triangle, what I'm going to do is just label this triangle a little bit differently, and doing that I'm going to label each of the 3 corners and each of the 3 sides that make up the triangle. So first of all, I'm going to label the 3 corners capital A, capital B and capital C. It doesn't really matter which of the 3 corners I've labelled which. The important thing is that they represent the capitals of A, B and C. And now to label the 3 sides, what I'm going to do is use the capital letters that we've just assigned to the corners. I'm going to use them as reference in order to name all 3 of the different sides. So let me begin by showing an example. The side opposite capital A, the angle would be this side right here, and that means that I'm just going to label this side small a. So small a is the side that lies opposite the angle of A. Now for side B, we have to figure out where the angle B is, which is this angle here, and the side opposite is going to be this side right here. So I'm just going to label that small b. And then finally for C, it's the last side, so it's the side that remains opposite. In that case it's going to be small c over this side here. So all I've did there is label the 3 angles capital A, capital B and capital C, and the 3 sides small a, small b, small c, and they all lie opposite its respective angle. And so by having our triangle labelled within this manner, we can use the following equation to represent the area of any triangle. And this equation can be read as follows. We can say that the area of any triangle is equal to a half multiplied by the length of side A, so this here, multiplied by the length of side B, and then multiplied that again by the sine of angle C, which is this angle right here. So what this really represents is, if we have a triangle where we know two sides, such as A and B, and we also know the angle that lies in between these two sides, so the angle that lies in between A and B, in this case it's C, then we can calculate the area of any triangle, because the equation says that the area is equal to a half AB sine C. And remember, when we have the sine of C, so the sine of an angle, this just represents a function, and in this case it's the sine function. So we're applying whatever known angle we have, in this case it's C for our equation, we're taking the sine function of that angle, and that is a value within our equation. And one important thing to remember is, it didn't matter how we labelled our triangle to begin with in terms of A, B and C, so it doesn't really matter in terms of what is which, and that would mean that we can calculate the area of any triangle only if we know two sides, such as A and B, but then also the angle that lies in between both of them, so C. So that would also mean that we could calculate the area if we knew A and C, but also the angle in between, which would be big B. So that equation would be a half AC multiplied by the sine of capital B. Or it could be in this form as well, where we have C and B are the known sides, but we have the angle in between this time, which is capital A. So this time the equation would be a half BC multiplied by the sine of A. So this is just a general form that indicates that in order to calculate the area for any triangle using trigonometry, what we need is two sides that lie next to each other and plus the angle in between the two sides. Put it into the equation and that will calculate the area for us. Okay, so let's have a look at our first example. Here we have a triangle and we've been given the length of two sides. So here we have a length of 3 centimeters and also a length of 7 centimeters right here, and also an angle of 35 degrees, and we've been given the task of calculating the area of this triangle. Now we've already been given the names of the three corners or the three angles within the triangle. We have A, B and C, so I'm just going to label the sides now. And to do that, well, first looking at where capital A lies, the side opposite that is going to be small a. The side lying opposite capital B is going to be small b, and the side lying opposite capital C is going to be small c. So to begin, what do we know from this triangle? Well, we know this length here, so length B. We also know length C, and we also know this angle, and this is an included angle that lies in between the sides B and C. And because we have two sides plus an included angle in between, then that means that we can calculate the area of this triangle. And we have the general form of the equation being a half AB sine C, with A and B representing the two sides and C representing the angle in between A and B. But for our case, our equation is going to change a little because of the sides and the angles that we've been given. In our case, our equation is going to equal a half BC, because that's the two known sides that we have of 7 centimeters and 3 centimeters, and the angle in between the two sides is A, so it's going to be a half BC multiplied by the sine of A. And now let's just put in the values. So we have a half multiplied by 7 centimeters multiplied by 3 centimeters multiplied by the sine of the angle, which is 35 degrees. And if we put this into a calculator, we should get an answer of 6.02255 and so on. But let's say we just want our area to 2 decimal places, then we can just say that our area is 6.2 and the units would be centimeters squared, because the lengths were given in centimeters. So that means that when we're dealing with an area, the area is going to be the units of the length squared, and because it was centimeters that we used, then we end up with centimeters squared in our final answer. And remember, this is to 2 decimal places. And just a little note, if you didn't get this answer but you followed along with the same steps, maybe just check to see if your scientific calculator is working in degrees. How do you check that? Well, when you look at the top of the scientific calculator, what you should see is a little letter D representing degrees inside a black box. But maybe you might see a little R inside the black box, and if that's the case, that means that when you go to calculate an angle, you're not working in degrees and you're working in something called radians. So if you didn't get this answer, check to see if you have the little D. If you have that, then it should be fine, but if you have the little R, then you need to convert your calculator from radians back into degrees. Okay, let's do one more example of looking at calculating the area of a triangle using trigonometry. This time we've been given this length here of 5 centimeters and this length of 8 centimeters, and we have this time an included angle of 130 degrees. So quickly I'm just going to label either side. So this one's going to be A because it lies opposite the angle of capital A. This would be B and this would be C. So our equation for the area will this time be equal to a half multiplied by the two sides that we have, so a half AC, and that's going to be the sine of angle B. And then if we put in our answers, we're going to get a half multiplied by 8 multiplied by 5 multiplied by the sine of the angle, which is 130 degrees, and we should get an answer of 15.32, and the units is centimeters squared, and this answer is given to 2 decimal places once again. So all we have to look for in a question like this is first of all make sure we have two sides that are known, and then also the angle that lies in between these two sides, and then it's just a case of putting it into our general equation, and in this case our equation was a half AC multiplied by the sine of B. We put in the values and that gave us our answer. So to end this lesson, I'm going to go through the proof of proving that this equation here, which we already knew, that the area of a triangle is equal to a half multiplied by the base of the triangle multiplied by the height, proving that this is the exact same thing as this equation right here. So to begin again, I'm just going to label the sides A, B and C, and we can see here for this triangle that we had in the first example, this length here, the base, is represented by B, and then here we have the vertical distance of the height. And we said that in order to figure out the area using trigonometry, we had to know two sides, like these two here, and also an included angle in between. And that meant our equation for this triangle became a half multiplied by BC multiplied by the sine of angle A. So I'm just going to use this equation instead of this one here. And looking at these two equations as they are, we can already see that they're pretty similar because both of them already contain the half part, and then we already have the base B featured in both equations. So now all we have to do is prove that H is equal to C sine A in order for both equations to be exactly the same. And the way we do that is by our knowledge on trig ratios. We can see here in this triangle already, we've formed another smaller triangle, and in particular it's a right angled triangle. We can see here that the vertical height H and then to point A and this length C here forms a right angled triangle. And if we draw this out, we can see here that we have this right angled triangle right here. And now using a little bit of trigonometry, first of all I'm just going to label each of the sides of the right angled triangle. We know that the side always opposite the right angle is the hypotenuse. The side opposite the known angle is the opposite. And here we have the adjacent side. And then thinking back to SOHCAHTOA, we can see that the sides that we are concerned with is this one here, the H, which represents the opposite, and also this length here, C, which is the hypotenuse. And we know the ratio for that is the SO, because that's the sine, opposite and the hypotenuse. And if we're to write this ratio out in full, we can say that the sine of the angle, which was A, is equal to the opposite over the hypotenuse, which would be the sine of A is equal to H over C. And then with a little bit of rearranging, what we want is h by itself, because that's what we have in this equation right here. To get that by itself, what we have to do then is take the c over to the other side, and because it's dividing on the right hand side, when we take it over, it's going to be multiplying. So that means we can say then that c multiplied by the sine of a is equal to h, and then that proves that both of these equations are the same, because what we were left with was h right here, and then c multiplied by the sine of a on this side, and if both of them are equal, that tells us that both of these equations for the triangle, calculating the area of the triangle, are both equal. Okay, so let's have a quick recap on this lesson we had on triangles. We learned that in order to calculate the area of any triangle, there are two ways of going about this. The first way here on the left is without using trigonometry, and it's the most basic way if we have the right values available to us. And it says that the area of any triangle is equal to a half multiplied by the base of the triangle multiplied by the vertical height. Whereas the second way here on the right tells us that if we know any two sides of a triangle plus an included angle that lies in between these two sides, then we can also calculate the area, and this is using trigonometry, as the equation says that the area is equal to a half multiplied by the two sides, so a half AB, multiplied by the sine of the angle, so the sine of angle C. So I hope this video has been helpful to you, and if that's been the case, be sure and give the video a thumbs up. But if there's still something that you're unsure about, drop a comment down below and I'll get back to you as soon as possible. And if you'd like to see more content like this, be sure to subscribe to our channel, and you should head over to our website at penguin-learning.com. Thanks again for watching, and I'll see you in the next video.